Hello, friends. You remember last time we were talking about data lakes and the Delta Lake. The Delta Lake, if you want, is an additional data storage layer on top of your data lakes. It interacts very closely with Spark, and today I want to show you what you can do, the operations within the Delta Lake metadata layer. So what we start right on from, streaming batch. Then here you improve your data quality, machine learning, business intelligence. I told you already in our last session. Now I'm using here on my current laptop, on a local machine. I install my Delta Spark. Already satisfied. Import my PySpark. And then I just start my Spark engine. So let's see this in real time. I have here now my Spark session in memory, my Spark UI. I have, local, I have all my 12 cores operational. Let's have a look if this is true. Should be 12. Yeah, I have all my 12 cores active. Storage memory is not optimized at all, but never mind, this is just for demonstration purposes. So first thing, now that we have Delta Spark up and running, we have to generate some data. 2 data sets I can generate here. I showed you already last time. And when we have here Spark data frame, we can very easily write this to a Delta table. So the data we have, the data is Spark range from 0 to 7. We write this to our table, and the table already exists. I had a feeling that this would be the case. So we have to do some housekeeping. The Delta table underscore already exists. Shit util is not defined, of course. Heaven's sake. I am not prepared at all today. I'm so sorry. But don't worry, we're gonna have this in a second. Whereas I do have somewhere, I know that I have somewhere. My do-do-ba-do-ba-do-ba-do. Come on, you're joking. I have somewhere my util. No, I don't have. There it is. My goodness, I'm so sorry. This, yes. So we have now a Delta table. And we can read now our Delta back into a Spark data frame. Here we go. We had 0 to 7, so we have 0 to 6. Yeah, this is it. If you want to make sure that this is indeed a PySpark data frame, yeah, you have either an SQL API or a Python API. I'm working here. You can mix both, by the way. I'm working here with Python. And yes, this is of course it. Yeah, you can also have, if you have a Spark data frame, then you can write it in a Parquet format. This is the thing you are familiar with. You store your data, your Spark data frames, simply as always in a Parquet format, and then you can convert it very simple to a Delta table. And if you want to have a short demonstration of this, cannot find the path specified, the Delta table. Oh, yes, of course, this is your Delta underscore table, and this is minus table. My goodness, today I'm really advanced today. So here we go, and the Delta table is not defined. Well, yeah, of course, it's no problem at all. Yes, it already exists. Heaven's sake. Today is not my day. So here we have it now. The Delta table, convert to Delta. We have Spark, we have our Parquet file, and now we have a Delta table. And of course, we can read the table, and now let's call it df dfa, dfz to dfz. Just we have no further problems here than the rate. Quite sure I do not have dfz at all. So here we are. We have here our Spark data frame in the range from 3 to 12. So we have here from 3 to 11. This looks good. We converted it to a delta table. We have now, you may ask, hey, what format is it? It is, of course, a PySpark data frame. But if you want to have a delta table, no problem. You have here a delta table for path. You define your path where your delta table is located, your Parquet file, and your transaction log. Of course, Spark. And yeah, you have here the confirmation. It's a delta table. And if you want to have a look, now surprisingly, it is exactly what we expect it to be. If you have a version, yeah, but I haven't showed you this, I'm going to show you in a second. You can have vacuum the table, or you can have the history of the table. You can even, if you want to use this data by Presto or Athena or whatever, you can have generate a manifest. But this is not it here. The basic operations on a Delta Lake. This is what I wanted to show you. If you want to read your original API, here you go, docs.delta.io, latest Delta update, and the language is Python. So here we go, just in case we have a Delta table, great. We have now a range from 0 to 5, and we save it as a Delta table again, and then we read it as a Spark data frame, and here we have from 0 to 5. Now, what we can do with the Delta table, and don't forget, we are talking about a data storage layer, so that we can manipulate our data from our batch processing, from our streaming, and we want to have a consistent, secure asset transformation whatsoever. So then we can create our, let's say, our data that we're interested in a Spark data frame, and continue with our machine learning or business intelligence or artificial intelligence algorithm, whatever. So what we do here is purely on a data level. And the first operation, if you want, we can do is override. We can override some previous data. Now I have here Spark range from 5 to 10. We had here from 0 to 5, now from 5 to 10. And I simply say, save it, write it, and a Delta format. The mode is override, and save it as a Delta table. And if you say, yeah, that's nice, but prove it to me, here we go. Again, we have from 5 to 9, 5 to 10. Of course, you can upsert. If you wonder what is upsert, it is simply a combination of update and insert or merge new data. You're quite familiar with this. Yeah, we have our Delta tables, our PySpark SQL functions, and then let's say you have your Delta table, and now you get new data in, and you want to merge this new data. So let's say we create some new data. We have here a Spark data frame from a range from 100 to 110. We want to make sure that it's a Spark data frame. And then, of course, we read our Delta table here from our path with Spark. And then we want to merge the new data and our Delta data in the Delta table. And the merge process goes like this. You have a Delta table, you merge, of course, with your new data, and then you have two set of instructions: when matched update and when not matched insert. Execute, and let's have a look at it. Now, if you're interested in the exact functioning of the command line match update and not matched insert, just for you to read, short summary that you understand a little bit, but I want to show you, we're here to code. So the first is here print the new data or a PySpark data frame. And then what we have our Delta table now converted to a data frame, Spark data frame. And what we have is now our new data. The new data is from 100 to 110, plus our old data, excuse me, and the old data was from 5 to 9. So we have 5, 6, 7, 8, 9, and then we have the data from 100 to 101, 102 to 109. So we merged our data. Of course, yeah, maybe I should show you, if you're interested in even more details, there's a very good documentation. It is on docs.databricks.com, Delta streaming. If you're interested in the streaming exercise, I'm going to show you a little bit afterwards. You have here the data science and engineering guide, best practice, and then you have your Delta Lake and the Delta engine, the Delta SQL engine. And the streaming, yes, but we're here on the operational side. So we have a table delete, a table update, and of course we want to merge in new data. So as you can see here, we have a SQL API, a Python, a Scala. So whatever you are interested in, I stick now for this demonstration purposes with Python. I think it is a very widely accepted language. And then you can see here, update the table, and exactly what we went through. Insert a table using merge. You have some semantic. You have some warnings, some schema validation, some automatic schema evolution, what is really, really nice. You have some details you want to get familiar. You can have some performance tuning, but this would be too much for our first introduction. What I just want to show you two more hints. The first is you have your operation with update, and you can say, for example, hey, update every even value by adding an integer of 100 to it. So you have your Delta table, you have the update command, and if you execute this, you see that now we have here, the last one was this Delta table, and now we updated every even integer with plus 100. So we should have the 200s should be even. So let's say 208, yes. 200, yes. 206, yes. 204, yes. 202, yes. And the rest stays as it was because it is not even. Then, of course, you can delete. You have a Delta table delete command, your expression that you want to delete. You can perform the operation and you delete everything that is modulo 2. So you are now left with 731599597. This is great, exactly as we think it is. The nice thing, of course, since you have asset transaction, is to show you the history of your Delta table. So what happened? These are here my timestamps. User. The operation we performed, the write, the merge, the update, and the delete that I just showed you. So you can see here an exact history, but much nicer is time travel. You have here the possibility to read old versions of your data. And I want to show you this. The very first version is the version 0. And do you remember what the version 0 looked? Yes, it was exactly the integer from 0 to 5. This was our data frame. Now version 1 that we performed was the operation that we override with the integer values from 5 to 9. This operation is here. And so you can go back in time, you can time travel back on your data layer, and you have all your data available. This is version 2. So you can see you have if we go back here, performance tuning, I want a very easy command. You have your delete, your update, and your merge command on your Delta Lake that sits as a meta layer on your data lake and forms itself the basis of the Lakehouse, the Databricks Lakehouse. Sorry, it's not my day today. And I just want to show you a professional code here by the Delta Lake project authors by Databricks. You can see here we import our Spark session, our Delta table. Then we start our Spark session, gotta create. We clean our Delta directory if you want. We create a table. We stream. We have a stream that writes to the table and a stream that reads from a table. It's very similar what you already know. Then you have some update mode. You can define it. Then you have your original Delta, the Delta table after streaming with the upsert, update and insert. Then you have the streaming processes, and what is really nice, after streaming, you can have a look at your Delta table, and you can clean up behind. So this is a program. You can test it out yourself. Here's the address, github.com, delta-io, delta blob master examples, Python, and streaming Python program. And this is it for today. Just to show you some basic operation on the data storage layer, Delta Lake, and convert a Parquet file to a Delta label. Yes, of course, you can convert it back. And then we are all ready what we know. So this was it, the program for today. I hope you're now a little bit more familiar with the operations you can perform on your Delta Lake that sits on top of you as a meta layer of your data lake. And these are the basic operation optimized for the streaming processes. And the nice part is you have here now a data lake with all the ACID transactions. So you combine the benefits from a data lake, flexibility, scalability, with the benefits from the old warehouses, parentheses, and this creates your Delta Lake, and this in itself forms the basis for the Lakehouse. And if you want to have an analogon for this picture, imagine there's a house on a beautiful lake, you have your data lake, on this data lake you have the layer of the Delta Lake, and the house right next to the lake is the Lakehouse by Databricks, where there are all the little people sitting there, the software developer and whoever, data engineers sitting there operating their Spark engines. And then they can do all their tasks that the CEO wants them to do, some business analytics, some business intelligence, some new dashboards that are updated every minute from all the 1,000 companies that they have. Or you can start directly, you can ingest this data into your artificial intelligence algorithm, into your machine learning, into the deep learning, whatever you want. So this is a very short introduction to Delta Lake and its operation on the Python API. Thank you.